Okay, guys. So today I'm again with another very beautiful uh, data structure problem, which is on array. The problem says maximum subarray. So it's very common problem, medium level problem, which is asked in many FANG group of interviews or companies. So I'll quickly go and understand, try to maximum subarray. So what does it mean? So you see here, given an integer array nums, find subarray with the largest sum and return its sum. So what does it say? So we have to find a subarray which has the largest sum in the whole array. So for example, let's say this is an array which has positive and negative numbers, integers in it. And if you check all the sub arrays like this, subarray should definitely mean that it should be contiguous subarray. So contiguous word is very very important to understand because it should be all consecutive. Like just how you cannot do, for example, taking -1 from here and then 2 from here and then calculating the sum. No, not like that. It should be all contiguous element sum, and that should be the largest in the array. Okay, so if you just do this and add all these numbers, it should give you sum 6. So this array has only this sub array which has the maximum sum. If you just calculate all the sub array sum, you will always get less than 6. Okay, and that's how other, like if you have only one element, it should definitely give you sub array 1. Then over here, this is where we have considered all the elements in the sub array, which is again 23. So yeah, that's the problem. Now, guys, think on it. You just come and take some time and just come with some ideas in the brain that what is clicking, what clicks your brain now. Sub array, right? So whenever we think about sub array, we got to know already that we have to look contiguous, sub array. So how you can get contiguous subarray? So there is a very brute force solution which is coming in the mind, and that is called finding each subarray sum and then making a uh max, I would say sum, and comparing it with this max sum for every subarray sum. And if you get the maximum one, return that particular subarray. But just think, uh, how does it actually it works? I mean, what is the time complexity and all, right? This is very important. You are calculating sub array. Um, so if there are n elements, and if you're gonna find, like, let's say there is a loop, one loop which is starting point of the subarray. You start from here, you're taking first index, and then you need one more loop inside this, like nested loop, which should add those numbers. So inner loop will be used to fix the ending point of the subarray, and outer loop you will take at the starting point of the subarray, and then only you will be able to get the sum. So you, let's say I starts at 0, and then your j will first do 2 1, and I mean -2 1 sum, and then it will do -2 1 -3 sum, then it will do -2 -1 -3 4 sum, and that way it will all keep on calculating the sum and comparing with the maximum sum, right? So this is going to be n squared time complexity. Okay, this is the brute force. I am not going to go with that particular solution because, again, as I said, you can talk these brute force always. It is always a good impression if you're talking those brute force solutions in front of the interviewer, but do not take too much of time. Rather than going deep into the code, just explain that this is the brute force, but I don't think this brute force should be used because there is another way, right, which can solve this particular problem in a better way, right? So there is some, there is one algorithm which is called a very popular algorithm, right, and which simply you know used, I would say, O of it does not use O of n square time complexity. Rather, it used O of n time complexity. and then do this, max sum in a very efficient way, right? So let me quickly, go to the code part, because if I start writing the code, it will be very easy for you to understand this algorithm. So over here, let me write the class, which will be maximum maximum sub array. Okay, so maximum sub array. You can say it like maximum sub array. It's easy. Or you can add like sum also here to make it more meaningful. And now, as I always do, I just copy this. Sorry. Let me copy this. And I just paste it here. Okay. All right. So this is the problem statement. And then always make things very simple. So if you want to make your, any problem, any complex problem simple, you need to just, uh, I mean, very high level, diagram of what you're thinking, and then write it down in more steps, like granular steps, which will definitely help you a lot. So over here, you see, I just uh, have my input array. So let me quickly nums, and then I just copy all the elements from here, which should be good. All right. And then this is my input, and my logic is, again, what is my logic? My logic wants me to have sum, right? So it should have max sum, and because we have to return the maximum sum, okay? And then I can say max sum, max sub array sum. All right. And in that, what we can pass nums. And then in the result, we can just wait, what? Something wrong. All right. Oh, now I got it. What's the problem here? I just forgot to have main, and it should be right placed here. Okay, that's why the IntelliJ was also crying. So let me quickly, yeah, so this is the way maximum. So yeah, this is what is very high level 360-degree view of the problem. Um, Input, logic, and result. Now we have to, write the logic for this. So let me go and create this method. And then what is this method? How this particular method actually going to play the role? Uh, this is very important. So this algorithm, uh, we have to, always, let me explain you. So we have to use two variables. We have to initialize two variables. One will be the max sum, and the other will be the current sum. Okay. So this variable, which is max sum, it will keep the track of the maximum sum of any subarray found so far. So let's say you are iterating in the array, and it will always be storing the maximum sum. That is pretty much clear, right? And then the current sum, okay, the other variable that we are maintaining as part of this algorithm, would be used to keep track of the current subarray sum. Okay, we iterate through the array. So these are the two variables, and then we will iterate the array starting from the second element. Okay, and then once we iterate, we start the iteration, current sum will always be updated with the current element, like num of I. Okay, so current sum will be updated, and max sum will always keep on checking maximum of, the previous one or the current sum, and then it will maintain. So it's very simple actually. So it works by recognizing that if the sum of the subarray up to a certain point becomes negative, right, it is better to start a new subarray. So that means start fresh from the current element. This way, the algorithm always looks the best, highest, I would say, possible sum without including proportions of the array that would decrease the overall sum. So, um, yeah, so that's how it works. So, two variables, uh, max sum and then current sum. So, let me write the code so that it is very easy for you to understand. As I said, max sum is equals to, so in the beginning, we can just start with nums of 0, and then we can have current sum. Okay, so this would be nums of 0. So these are the, starting steps, which is very simple. We are initializing max sum and current sum. Now, as I said, I have to iterate. So I'm just iterating. Where am I iterating? I'm iterating on my nums array, and this is where my nums array works in. So what is current sum? Current sum, as I said, will always maintain uh, what it will maintain. Okay. So I can say current sum plus nums of I, right? This is something which comes straight away in our mind, correct? So current sum will always be the sum of this. This will be the current sum. But hold on. We always have to, calculate this current sum with a consideration that we have to always consider very tricky part here. Let's say my current sum is, keep on, getting calculated like this. But let's say the current element that where I am, okay, that element has, is that element is more than whatever the sum we have calculated. If that is the thing, that simply says that we have to choose the maximum one. So what does it says? It says that we have to use math.max, okay, eliminating all the, okay, let me write it this way, and then we will understand more. So what this will do, this line will simply eliminate all the cases, okay, it will eliminate all the cases where there is a possibility that your current sum plus nums I is less than the nums I itself at index I position. Okay, so that's what these two lines means. Okay, so this particular line, again I'm explaining you, it decides whether to continue the current subarray or start a new subarray, right, beginning at the current element nums I. So this current sum plus nums I, this adds the current element nums I to the existing current sum, continuing the subarray. So this part says we are continuing the subarray. Okay, this approach makes sense if the previous subarray sum was positive. Okay, and as as we are adding the current element could potentially increase the total sum. And this nums I, this option simply sets current sum to the current element itself. Okay, this choice effectively starts at a new subarray nums I. Okay, this is new subarray nums I, ignoring the previous sum if it would reduce the total. So this option is selected when current sum plus nums I, okay, the total sum is less than nums I, okay, indicating that subarray would benefit from the start, uh, from a fresh start rather than the previous maximize, the previous total. So this is the way how we are, making sure that uh, that whether to continue the current sub array or start a new sub array beginning at the current element, which is at nums I. Okay, and then the second line, which was like calculating max sum, it will be very simple because we have to just say math dot max. Okay, and there it will be max sum and current sum. That's all. And that's, I think this line is pretty straightforward. This line keeps the track of maximum subarray sum encountered so far. Okay. And then we return max sum. And that's how it this particular problem. Let me quickly run this particular problem and see how it works. So this says 6, and here it is. This is 6. Let me play around with some other samples so that we see, we make sure this solution works for all, and then we'll hit it to LeetCode. Okay, this says 10. Is it meet? All right, so there is something. I just copy paste it. Okay, this is example 1. All right, there is some formatting error, and that is why I just copied the wrong. So I just copied this, which is an answer. So let me copy this num_i, and then I just do this, and it should be 2 nums of, okay, this nums has 1 and output is 1. So there is some problem over here. Okay, let me quickly check what's wrong here. All right, so I got the problem because I'm starting from 0 index. We should not, because we're already considering here the nums 0 position, right? So now run this, and here we go. It is working. And I'll run it one more time for this, my previous example, and run it here. 6. Let me copy this. Okay, and run this. It's 23. So all good. So yeah, this is how it works. Let me copy the solution from here. Go to, okay, before we go, I just need to talk about the time complexity. So as I said, we could have done this particular solution in a brute force way. Okay, making 2 arrays. One array would be, the outmost array, starting element, picking the starting element. I mean, it's very simple. 2 nested loops. One will pick the start element, and the inner loop will, make all the sub arrays like j plus 1, j plus 2, j plus, till n. So that was O of n. But this way, where we maintain 2 variables, and just by utilizing this tricky way, we try to achieve our solution time complexity into O of n. Yes, you're right. This particular line which says continue the current subarray, or you have to start a new subarray. Okay, that's where the trick comes in. And so time complexity now is O of n, and space complexity is O of 1. Yeah. So that's pretty much all. Now we will test our solution here, and let's just put it and then run it. Good. It accepted, submitted, and that's good. It is accepted. So thank you very much. We see you in another video.